All right, let's take a look at the assignment sheet. See what's happening these last 2 weeks. So today, this is the last lecture, of the whole semester. So Polar 5, this is like a practice test. Wednesday's assignment, study for tests. We're not going to go on to the next section, and then the test is this Friday. So I guess if we continue on, like I'm going to probably just give you tests on subjects that are really important for BC Calculus. So like next semester, the first chapter is on conic sections, parabolas, ellipses, hyperbolas. That one is not so important in calculus, so we'll probably just get quizzes during that chapter. But then the next 3 are really important. We'll see. I'll just have to go chapter by chapter. Anyway, and then next week, we're just going to review for the semester exam. I have a review worksheet on the Google Drive. And then your test is 10:15 on Thursday. I'll give you the room number later. It's somewhere over here. And then you guys know how semester exams work, right? That's like 10% of your final grade, yeah? So each quarter is 20% and each semester exam is 10%. That's pretty much every math class does the same thing. So now that, some of you are 11th grade, right? Some of you are 10th grade, yeah? But the 11th graders, you're going to get, starting this year, you're going to start getting semester grades. You know what they use the semester grades for? To rank you. Except they don't make it public. They're not going to print it on your report card or anything like that. So, to get your semester grade, if you're 11th grade or higher, it's simply the average of the first and the second semester. But that's all the administration uses it for, just to rank you. Because they want to know who's number 1 and who's number 240, whatever. Okay, so that's what's happening the next 2 weeks. So the first thing we're going to do is we're going to go over this quiz, even though a lot of you got 48, 49, or 50, right? But we have to understand this because today's lecture is like the toughest lecture of the whole chapter. You got to know all of this. Yep, so we're going to use this as review. So number 1, convert the polar point into rectangular coordinates. The easiest way to do this is to use the formula. Remember, x equals r cosine theta, y equals r sine theta. And then you just got to know your trig values, right? And again, yes, you still have to know your trig values and trig identities all the way till you finish your math career. Okay, cosine of 5 pi over 6. Have we forgotten how to do that? We need another speed quiz. Negative root 3 over 2. Sine of 5 pi over 6. 1/2. And then you simplify. So negative 4 root 3, 4. So your answer is negative 4 root 3, 4. That's the easiest way to convert from polar to rectangular. Use the formulas. Okay, number 2, convert the rectangular point 0, negative 4 to polar coordinates. Now, some people are using the formulas. I remember at least 5 or 6 people trying to use the formulas. I told you that's the hardest way to do it. Just draw the picture. When you want to convert from rectangular to polar, just draw the picture. It's so easy. So if you plot the point 0, negative 4, isn't that right there? How far from the origin are you? Really? 4. And what is this angle going around like that? Isn't that 3 pi over 2? Yeah, you don't need any formulas for that. Or if you want to go negative pi over 2, you can. Some people did some creative things with that, but this is the most common way to do it. And then number 3. How do you find the distance between 2 polar points? Draw up a picture and use the law of cosines. All right, so the first point is 850 degrees. So draw a 50-degree angle and go 8 units from the origin. And then the next point, draw a 110 degree angle and go 5 units from the origin. So how do I find this distance between the 2 points? So I just call it x then. Well, if this angle is what? 50, and that angle is 110, then what is this angle right here? Isn't that 60? Just subtract the 2 angles. So if you know 2 sides and the included angle, how do you find the third side of a triangle? I put the quiz on your desk. The law of cosines. Do you remember the law of cosines? X squared. I guarantee you this is going to be on the test. X squared equals 5 squared plus 8 squared minus 2, 5, 8 cosine of 60 degrees. And again, the most common mistakes, people put plus here, people forget the 2. And in this year, I think this is the first year in a long time that everybody wrote cosine. There's always 1 or 2 clowns that put sine, even though it's called the law of cosines. Don't ask me why. Anyway, what do we got here? 25 plus 64 minus, now cosine of 60 degrees is 1/2, cancels the 2, so 5 times 8 is 40. So you got 89 minus 40 is 49. Therefore, x equals plus or minus 7, but a distance cannot be negative, so 7 is your answer. Okay, number 4. Change, and look, I didn't even ask you to graph this. Maybe that's why everybody got high scores, yeah? Don't worry, you're going to do a lot of graphing on the test. R equals 3 over cosine theta. On this quiz, you just have to change it to a rectangular equation. So if you cross multiply, R cosine theta equals 3. And if you somebody, that's x equals 3, vertical line. Easy. Hey, how come there's another A there? Yeah. Second A. R equals -4 sine theta. Okay, so what you want to do is you want to get R squared, but then you also want to get R sine theta, so multiply both sides by R. R squared equals -4 R sine theta. And then, hey, you somebody. And then, hey, you somebody. But then it says to leave your answer in standard form. That means the form that you can just look at and draw the graph. No. So you need to complete the square. Okay, so leave a space right there. What do I have to add right there to make a perfect square? You take half of that number. Next chapter we're going to be doing this like almost every problem, you know. So you're going to be good at it. Take half of that number and square it. 4. Add 4 to both sides. So you get x squared plus y plus 2 squared equal 4. That is standard form. See, by just looking at it, you know the center is at 0, -2. And the radius is the square root of that number, right? You have to know that on the SAT and ACT, right? Okay, B. R equal to √2 cosine theta minus pi over 4. So cross multiply. And then expand, right? So you got to use identity. What is the identity for cosine of gorilla minus banana? Cosine gorilla, cosine banana, plus sine gorilla, sine banana. And then if you distribute the r, you get r cosine theta, and of course cosine of pi over 4 is either right √2 over 2 or 1 over √2, doesn't matter. I think in this problem 1 over √2 will come out nicer. And then r sine theta, again 1 over √2 equal 2 √2. And then look, you somebody, you somebody. And then if you want to get rid of these, multiply both sides by √2 so you get 4. So you just get a nice line, right? X-intercept 4, Y-intercept 4, easy to graph. And then C. C, theta equals 3 pi over 4, so you tangent both sides. Some people didn't do this for some reason. Why do you tangent both sides? Because A, use somebody. Tangent theta is y over x. Tangent 3 pi over 4 is -1, so y equal -x. That's another line, right? And then the last one, I guess this was the, if points come off, it came off this one, because you gotta actually do algebra. So cross multiply, 2r minus 3r sine theta equal 10, and then A, use somebody, that's y. But we still have an r here, so we need to isolate this term. So you get 3y plus 10, and then square both sides. So you got 4r squared, because you want r squared, because r squared is x squared plus y squared. And then be careful when you multiply this up. I think I remember some errors here. 60y plus 100. And then of course this is x squared plus y squared, so distribute the 4. You get 4x squared plus 4y squared equals, let's see, 9y squared plus 60y plus 100. Okay, now you need to put it in standard form. So you put all the x's together, there's only one x term. Now you put all the y's together, so bring this over, so minus 5y squared minus 60y equal 100. Leave the number on that side. Factor out a -5. And you're going to get y squared plus 12y. I think that was a mistake right there. Oh, now I remember correcting this quiz. See, if you didn't factor out the minus sign correctly, it should be a -2, but I think I just took off 1. Anyway, what do I have to add here to make a perfect square? You take half of that number and square it, so 36. But what did you actually add? -5 times 36, which is -180. So this is what you got, 4x squared minus 5y plus 6 squared equal -80. And then to get it in standard form, because this is going to be a hyperbola, right? Anytime you have an ellipse or a hyperbola, this side has to be 1. So how do I make that side 1? Add 81 to both sides. No, you divide by -80. So if you divide this by -80, you're going to get minus x squared over 20. If you divide this by -80, you're going to get y plus 6 over 16, right? There you go. That is standard form for a hyperbola or ellipse. The only difference is if it's a minus sign, it's a hyperbola. Plus sign, it's ellipse. Anyway, this is standard form because then you know the center is at 0, -6. And I didn't even ask you to graph it. However, on the test, you might have to graph it, so why don't we practice it? And like I said, I don't expect much from you, but I expect you to graph it. I don't expect you to find the foci and the directrix and the latus rectum and things like that. So, the center is at 0, -6. There. And then this number is a squared, this number is b squared. I don't know if you guys remember that. Anyway, what's the square root of 16? 4. That tells you how much to go up and down from the center. So from the center, you go 4 up, 1, 2, 3, 4, and 4 down, 1, 2, 3, 4. And then you take the square root of that number. Square root of 20 is what, 4 point something, right? So what you do is you go 4 point something to the left, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so, and then you make the rectangular box. See, if this was a plus sign, the only difference is you just connect those points you just plotted, you get the ellipse, but it's not. Drawing the diagonals. And then since the y comes first, then it's going to be an up and down hyperbola. So it's going to be if the x came first, it would be a left and right hyperbola. I didn't ask you to graph this one. Okay, and then the last page, these are all base graphs, yeah? So I hope you guys didn't purge everything. R equal -5 cosine theta. This is going to be a circle. To graph a circle, all you have to do is what? Plot 2 points, 0 and pi over 2. Okay, what happens when you plug in 0 for theta? Cosine of 0 is 1. 1 times -5 is -5. So 0, -5. So in other words, measure off an angle of 0 and go 5 units in the opposite direction. Then you plug in pi over 2. Cosine of pi over 2 is 0. So you're 0 units from the origin. You see these 2 points? Those are the endpoints of the diameter. So what, you got a semicircle here and a semicircle there. But you got to remember, that's not how it's being formed, you know. Remember, it goes like this: 0, pi over 2, pi. So you can actually draw the entire circle from 0 to pi. That's going to be important, you know, on the test. 3 pi over 2, and then 2 pi. So if you graph it from 0 to 2 pi, it actually goes around twice. Super important. Don't worry, I'm going to test you on that. R equal 2 plus 2 sine theta. Okay, so when this number is the same as that number, cardioid. Anyway, to graph any of the limosomes, just plot the 4 quadrantal angles. So if you plug in 0, you get 2 plus 0, which is 2. Plug in pi over 2, so you get 2 plus 2 is 4. Plug in pi, sine of pi is 0, so you get 2. And then if you plug in 3 pi over 2, you get 2 minus 2, which is 0. See how the placement of the 4 points tells you what it's going to be? So if this point was out here, you would have the monopole. If this point was in here, you would have the inner loop, but it's not. It's right on the origin, so this is the cardioid. So, well, this side is a little too flat, and that's a little better. So this is a cardioid blowing to the south. I wasn't too picky on the graphs. Some of you made it a little too emaciated. But you guys, right, you guys graphed it on your calculator. You guys should know what a cardioid looks like by now. It's nice and healthy. C, R equal 2 minus 3 cosine theta. Okay, when this number is smaller than that number, that's the inner loop. But you don't even have to know that. If you just plot the 4 quadrantal angles correctly, you'll see that it will be an inner loop. Okay, so plug in the quadrantal angles. If you plug in 0, you get -1. Plug in pi over 2, you get 2. Plug in pi, you get 5. 1, 2, 3, 4, 5. And again, you got to go in the direction of the angle now. Plug in 3 pi over 2, you get 2. See how this point is inside there? That's why it's the inner loop. If this point was there, then that would be a cardioid. If this point was out here, you get the monopole. So it goes like this. What's the first point I plotted? Like this. So, and I'm looking for, did your graph pass through the origin? All inner loops have to go through the origin. Why again? Because look, at 0 it was -1, but then when you plugged in pi over 2, it got 2. So to go from -1 to 2, don't you have to hit 0 in between? Look, here's -1, here's 2. This is rectangular coordinates now. To get from here to here, don't I have to cross the x-axis somewhere in between? Isn't the y-coordinate 0 there? So same thing here. So remember the reason? What's the reason? Come on, you guys are going to impress your BC calculus teacher next year. The intermediate value theorem. To go from negative to positive, you have to hit 0 somewhere in between. So that's why if your graph doesn't go through the origin, you will get a point taken off of that. D. Let's do it here. I've got 2 more graphs. R equal 4 cosine 5 theta. This is going to be a rose curve. If this number is odd, that means you're going to have that many petals. So there should be 5 petals. Each petal is 4 units long. So the easiest thing to do here, I guess, draw a circle of radius 4. Or just draw a circle and go, okay, that's 4. Whatever. Okay, how do I know where the first petal is? Well, cosine reaches its maximum value of 1 at 0. So whenever this is equal to 0, that's when you're going to have the tip of the first petal. So theta equal 0, right? 0 divided by 5 is 0. So 0, and then if you have 5 petals equally spaced apart, that's going to be important in today's lesson too. 360 divided by 5 is 72. So every 72 degrees, you're going to have another petal. So add 72 degrees, 144 would be about there. What's 144 plus 7? 216 would be about there. What's 216 plus 72? 288. So 270, So the circle looks bad. I don't like it. It's probably more over there. Okay, so the first, and remember the petals do not overlap now. So the way I'm drawing this is not how it's being formed. I'm just drawing it. Actually, if you were to graph this on your calculator, but again, your calculator does it so fast you can't see. It actually does this. That's not actually right. I think it's like this. Let me start over. Yeah, that's more like it. Anyway, like I told you before, it's not enough to draw the graph. You got to know how it's being formed. Because next year in calculus, if you want to compute the area of one of these, which you're going to do, you got to know where it starts and when it ends. Don't worry, that's going to be on Friday's test too. Don't worry, it's in the practice test. And then E, r squared is equal to 9 sine 2 theta. When that's an r squared and that's a 2 theta, this is a lemniscate. A lemniscate is a figure 8. You just got to figure out where the tips of the petals are. And again, if it's sine, sine reaches its maximum value of 1 at 90 degrees or pi over 2, right? So when this is equal to pi over 2, that's where you're going to have the tip of the lemniscate. So divide by 2, so theta equal pi over 4. So what I would do, I would draw a circle of radius 3. Some of you did 9. It's not 9 because you got to square root it to solve for r. Okay, so what happens when you plug in pi over 4 here? What is 2 times pi over 4? Pi over 2. Sine of pi over 2, 1. 1 times 9 is 9. If r squared is 9, what is r? Plus or minus 3. So not only do you have 3, you got negative 3 here. So you got one petal of the lemniscate there, and the other one's going to be there. That's a little too thin. Should be a little more healthy. Yeah, that's more like it. And no, you weren't quizzed on it, but remember we actually went over polar 3. Sometimes you got to plot points to get the graph. That's what you have to do. And then you got to find where they intersect. So you know the intersection of the polar curves is going to have 2 of those problems on the test, and each one is like 12 points each, you know, because you've got to do a lot of work. All right. So today we have the last lecture of this chapter. So let me put this up on the screen so I make sure I teach you everything. Polar. Ooh, there you go. That's tonight's homework. Hey, tonight's homework doesn't look too bad. Well, you got to know things, though. That's the thing. Now, are there applications of polar coordinates like in real life? Yes, complex numbers. Which means, why do we study complex numbers? Just so teachers have jobs? No, because you can use it in electrical engineering. That's how you analyze alternating current. Did you guys start studying that in physics yet? What's physics? All right, so how can you apply polar to complex numbers? Okay, well, let's go back. When did we learn about complex numbers this year? In Lin Quad, right? Oh boy. Here we go. What is a complex number? It's a number that can be written as a plus bi, right? Complex numbers are usually represented by the lowercase letter z. A is called the real part, b is called the imaginary part. And remember what I told you back then? What is a complex number? Exactly. It's a... Okay, let's play hangman. I'll even give you the vowels. What is a complex number? It's a... Give me a letter. And don't say A. I gave you all the vowels already. Again now. No, you lose. Oh, that was an easy game. It's a vector. It's a vector. That's what a complex number is. It's a vector in the complex plane. Okay, so you guys are used to the Cartesian plane where you have the x and the y axis. But the complex plane, it has a real and an imaginary axis. Okay? Now the real part is A. So what you do is you go A to the right and B to the up if A and B are positive. You know what? We should look at a concrete example. Why don't we go 4 plus 3i? Okay, the real part is 4, the imaginary part is 3. So basically, you plot the point 4, 3 in the complex plane. So you go 4 to the right and 3 to the up. You plot that point, but it's a vector, and you guys in physics should know what a vector is, right? And if you don't know what a vector is, it's an arrow. It's an arrow that points from the origin to that point. So, that's what a complex number is. It's a vector in the complex plane. So you just think of that as the point 4, 3. Draw an arrow from the origin to that point. That's how you make the vector. So yes, we can do many things with vectors. We're going to study that in the third quarter. That's a whole chapter in itself, vectors. See, because right now in physics, I think you guys just do baby vectors, but then we're going to do grown-up vectors in the third quarter here. Okay, so this is the way we represent vectors, a plus bi. But then, in order to use the really good theorems that I'm going to teach you, you have to change it into what we call polar form, which looks like this. Instead of a plus bi, we write r kiss theta. See, r and theta are the same r and thetas that we learned in the polar coordinate system. See, so when you draw a vector like this, see, this is a and this is b, right? R, you can probably guess, is the length of the vector, and theta is this angle right here. Isn't that the same thing as polar coordinates? That's why we call it polar form. Now, r kiss theta is actually an abbreviation for r times cosine theta plus I sine theta. Right? Because isn't A equal to r cosine theta? Look at this picture. Right? And isn't B equal to r sine theta? Oh boy. Look, if you have the hypotenuse of a right triangle and you know this angle, how do you find the adjacent side? R cosine theta. How do you find the opposite side? R sine theta. If you don't have this skill, then you cannot componentize vectors in physics. Okay, so if A is equal to r cosine theta, plug that in for A, and B equals r sine theta, isn't that the same thing as this? It's just in a different form. So this is called polar form, but we don't like to write this out, so that's why we abbreviate it, r kiss theta. Now some teachers say r cis theta, but then C stands for cosine, not cosine, right? So it's r kiss theta. That's why I have it written there. You see the kiss? That's an abbreviation for r cos times cosine theta plus I sine theta. So the first thing you have to do is you have to be able to convert back and forth. Okay, so here we go. Let's go from here, what if I give you this? 4 kiss 2 pi over 3. How do you change this back into a plus bi form? We call that standard form. Well, it's easy. All you have to remember is KISS is an abbreviation for what? I just have it right up here. Cosine theta plus I sine theta. That's what it's an abbreviation for. And then now you just got to know your trig values. What is the cosine of 2 pi over 3? Negative half. And then what is the sine of 2 pi over 3? Root 3 over 2. And the I always goes with that one. Distribute the 4 and you get negative 2 plus 2 root 3I. So that's how you convert from polar to standard form. You just got to remember what the KISS is an abbreviation for R cosine theta plus I sine theta. Now what about the other direction? How do you change it from standard form to polar? What did we do in regular polar coordinates? What did I tell you? So like this one, basically you use the formula, right? But what if you go the other way around? How about negative 4 root 3 minus 4? Sorry, need the I there. How do you change that into polar form? We just went over it on the quiz. Draw the picture. Don't use, you can use formulas if you want. Just draw the picture. Except this is not x and y, it's real and imaginary. That's what it is. So if I go 4 root 3 to the left and 4 down like this, how far from the origin am I? So here's the vector. What is the length of the vector?
8.
8. How do you know it's 8? Because if one leg is radical 3 times the other, isn't this a 30, 60, 90 degree triangle? And in a 30, 60, 90 degree triangle, then isn't the hypotenuse double the short leg? I mean, you can use the Pythagorean theorem if you want, but come on. Almost all of these things that you're going to get, it's either going to be 30, 60, 90 or 45, 45, 90, right? And then, if this is the 30 degree angle, what is this angle going around like that? What's 180 plus 30? 210, or 7 pi over 6. So the polar form for this will be 8 KISS 7 pi over 6. This is exactly what we did before. The only difference is instead of putting a comma, we put a KISS in between. It's the same thing. You guys get it? I don't know, I don't trust you. Gotta do some more. How about negative 3i? How do you change this into polar form? Well, I would highly suggest you put the 0 there first. 0 minus 3i. And then you plot the point 0, negative 3. If I plot the point 0, negative 3, right there, how far from the origin am I? Or what is the length of the arrow? 3, and then what's that angle going around like that? Really? 3 pi over 2, or if you want to go negative pi over 2, you can. This is exactly how we convert from rectangular to polar in the regular coordinate system. Like I said, the only difference is instead of a comma there, you have a KISS. Same thing. Okay, now that we can do this, now I can teach you the theorems. Yeah, I'm going to erase all of this because we have to stay on the left side of the board. What time is it? Oh yeah, we're going to finish. Okay, so the first theorem, this is all in the notes now. If you look at the notes, it's all there. You don't have to write down anything. Let's say you have two complex numbers. The first complex number is R1 KISS theta 1. See, so in order to use these theorems, the complex numbers have to be in polar form. Okay? Z2 is R2 KISS theta 2. Okay, now before we do this, let me ask you this. Let's say you have two complex numbers. 2 plus 3i, and then you have to multiply that by 1 minus 4i. How long would it take you to do this, you think? Simplify this. Okay, well, let's time ourselves. Okay, multiply it out. Never mind, Mr. Park, about 5 minutes. No, come on. This is less than a minute. Come on, multiply it out. 2 you have to do everything, minus 8i plus 3i minus 12i squared. But what is I squared again? Negative 1, so that's like 2 plus 12. Really? 14, and what is negative 8i plus 3i? There you go. Right, you guys did this in Algebra 2. It doesn't take that long, but it takes work. And then what about dividing? What if you had this divided by this? What do you have to do? This is on the SAT. You gotta multiply top and bottom by the conjugate of the denominator. And then how long is this gonna take you? Maybe a little more than a minute, because you gotta do top and bottom, right? Yeah, so yeah, you can do it, but it takes time. But watch this. That's why we have these theorems, because it makes life easy for you. If the complex numbers are in polar form, then when you multiply them together, all you have to do is multiply the r's and then add the angles. That's how simple it is to multiply. You guys don't seem impressed. This saves you so much time. And then what about dividing complex numbers? You can probably guess. What are you going to do? You divide the r's, and what do you think? You're going to subtract the angles. Believe me, it's way faster than this. Anybody want to erase me? Here, let me give you a concrete example. Let's say Z1 is equal to 8 kis. Shall we work in degrees or radians? Let's do degrees. How about 120 degrees? Z2 is equal to 2 kis 90 degrees then. Okay, what if I tell you, okay, multiply these complex numbers? Well, follow the theorem I just showed you. What is 8 times 2? 16, and then add the angles. Really takes 210 degrees. Finish, that's it. I just multiplied them. That's so simple, it's so fast. You can do it in like less than 5 seconds. And then of course, most of the problems on the test, you're gonna have to change it back into a plus bi form. And remember how to do that? We just did it 5 minutes ago. What is KISS an abbreviation for? Cosine 210 plus I sine 210. After a while, you don't even have to write it down. You just do it in your head already. Okay, what is the cosine of 210 degrees? Okay, I'll just do all the work then. What is the sine of 210 degrees? Negative half. I always goes on the second one. Distribute the 16 and you get negative 8 root 3 minus 8i. There's your answer. I guarantee that these problems are all on the test. Okay? Okay, what about Z1 divided by Z2? Well, follow the theorem. What is 8 divided by 2? 4. And then you subtract the angles. What's 120 minus 90? 30. There you go. That's the answer. That's the answer. And then we change it back. Okay, now here, let's use a shortcut. Now remembering, KISS is an abbreviation for cosine theta plus I sine theta, right? So here, watch this. You can save a lot of steps here. What is the cosine of 30 degrees? Root 3 over 2. What is the sine of 30 degrees? 1/2. The I always goes with the sine thing and then distribute the 4. 2 root 3 plus 2i. Here's your answer. In fact, some of you can just go from here to here. You just got to do it a few times. Okay, now some of you weren't too impressed by this theorem right here. Okay, I'm going to show you another one then. How long would it take you to do this problem? 2 plus I to the 10th power. How would you even expand 2 plus I to the 10th power? What did we learn in the first quarter? The binomial theorem. By the way, on the final exam, there's quite a few problems using the binomial theorem. Do you guys remember? So how long would it take you to do this? Because if you don't remember the binomial theorem, what are you going to do? Multiply it by itself 10 times? Mr. Park, I'm good at that. Are you kidding me? Well, watch this theorem here. See, if the complex number is in polar form, r KISS theta, Now, when you raise it to the nth power, all you have to do is raise the r to the nth power and multiply the angle times n. That's super fast. Okay, here, let me give you a problem. Let's say you had, yeah, I'm trying to think here for you. Root 2, okay, root 3 plus I, yeah, let's do to the 10th power. Okay, so you can do it the binomial theorem way. I don't recommend it. I would use this theorem here. In fact, you know what this theorem is called? It's called de Moivre's theorem. Named after the mathematician Abraham de Moivre. You guys don't understand how powerful this theorem is. Because look, like I said, how long is it going to take you to raise something to the 10th power? I would bet some money you guys, I could give you the whole period and some of you still get it wrong, right? Yeah, because there's so much computation. That's why all we have to do, if I want to use de Moivre's theorem, is change this to polar form, arc his theta. Remember now, to use all of these theorems, you have to change it to polar form. So, what's the fastest way to change from a plus bi to polar form? Were you guys here 10 minutes ago? Draw the picture! The only difference is instead of the x and y axis, it's the real and the imaginary axis. So if I go root 3 to the right and 1 up, how far from the origin am I? 2. How come it's 2? Because again, it's a 30, 60, 90 triangle. Now what's that angle right there? 30 degrees or pi over 6. I don't care if you write degrees or radians. I just use them interchangeably. Okay, now use de Moivre's theorem. What does de Moivre's theorem say? How do I raise this to the 10th power? You raise the 2 to the 10th power. What is 2 to the 10th power? Oh boy. I thought we had that memorized. You guys should have your powers of 2 memorized up to 10. Okay, it's 1024. Kiss, and then what do I do with this angle? What does it say to do? You multiply that angle times 10. What is pi over 6 times 10? And don't say 10 pi over 6. 5 pi over 3. That's the answer. Why do you want to use the binomial? Don't tear this. Why do you want to use the binomial theorem when you just do this in like 10 seconds? Because I like to do unnecessary work, Mr. Park. Okay, now on the test, you're going to have to change it back into a plus bi form, but I already taught you how over there. So what you got to do is, okay, let's see if we can just do it in our head. What is the cosine of 5 pi over 3? 5 pi over 3 is over here, people. What is the x coordinate of that point? 1/2. What's 1/2 times 1024? Okay, if we kind of divide a number by 2, let's just go home already. 512. What is the sine of 5 pi over 3? What is the y coordinate of that point? Negative root 3 over 2 times 1024. Minus 512 root 3, and then you simply put the I on the second one. Boom, there's your answer. You can actually do these things in your head. Impress people at parties. Except we can't have parties anymore. See, you guys are not impressed by it. Oh, but that... Oh, yeah. De Moivre's theorem. Super powerful. Okay, last thing. If you look, okay, so if you look on your sheet, the notes, okay, I'll write it out. This is called the complex roots theorem. Okay, here it is. If you have an equation like this, z to the nth power is equal to r cos theta. See how it has to be in polar form again? First of all, how many answers are you going to have? N. You're going to have N. Okay, look. When you have an equation like this, z cubed equal 8i, or something like that, how do I know I'm going to have 3 answers? Remember we did this in the first quarter? If you have a polynomial equation of degree 3, what tells you that you're going to have 3 solutions? The fundamental theorem of Algebra. I'm getting depressed here. Okay, anyway, so to find your n solutions, you simply use this theorem here. This is written in the notes. You don't have to copy this out. The nth root of r, kiss, theta, plus 2k pi all over n, where k is equal to 0, 1, 2, dot, 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 n minus 1. Boom, this is the complex roots theorem. Okay, so we got how much? We got about 6 minutes left. Okay, let me show you how it works on a concrete problem. What if in fact, let's do this one right here. Z cubed equals 8i. How many answers are there going to be? 3. Okay, what are the 3 answers? Well, what you have to do is you have to change this into polar form so you can actually use this theorem. So what I would highly suggest is put the 0 there to help you. Okay, what's the fastest way to change from standard form into polar form? Should I use the formula or draw the picture? Draw the picture! I keep telling you guys that. I don't know why some of you want to use the formula. Okay, plot the point 0, 8. 0, 8 is up here. How far from the origin am I? 8. And what is that angle right there? Pi over 2. It's so simple. Just draw the picture. Okay, now that we got it in polar form, just use this formula. Okay, this is, here, let's identify everything. What is this? That's n. What is this? R. And that's theta. Just plug and chug into this formula. It's so simple. So your solutions will be the cube root of r, which is 8. See how I make it come out nice? Cube root of 8 is 2. Kiss theta, which is pi over 2, plus 2k pi, all over n. What is n? 3. Where k is equal to 0, 1. When do I stop? You stop when you get to n minus 1. So if n is 3, what is 3 minus 1? 2. So what do you think? How am I going to get my 3 answers? You plug in these 3 numbers for k. That's how you get your 3 answers. Okay, so your first answer is, what is the cube root of 8? 2. Okay, so the first answer is you got to plug in 0 for k. Let's see if we can do this in our head. So what is, if k is 0, isn't this whole thing 0? What is pi over 2 plus 0 divided by 3? Pi over 6. See, you can do it in your head. That's the first answer. The second answer is going to be 2 kiss. Okay, now, can you plug in 1 for k? Let's see if you can do that. Plug in 1 for k. So you get pi over 2 plus 2 pi. 5 pi over 2 divided by 3. 5 pi over 6. Hey, that's your second answer. And then the third answer is, now you plug in 2 for k. Let's see if we can do that in here. Plug in 2 for k here. Pi over 2 plus 4 pi. 9 pi over 2 divided by 3. 3 pi over 2. There you go. Those are your 3 answers. Okay, but I want to show you something that can reduce the amount of work you have. Let's actually graph these 3 answers. Now remember, a complex number is a vector now. So what if I draw a circle of radius 2 here? How do you draw this vector? Well, it's going to be 2 units.